So today we're going to actually start learning Target 5 using our understandings of multiplication and division to divide fractions by fractions. So today the lesson was about having students tap into what they already know about multiplying and dividing whole numbers and multiplying fractions to begin to learn how to divide with fractions. What was the big idea that we learned when we multiply fractions? What happens to the product when we multiply fractions?
I was going to say that it cuts in half most of the time.
So let's look back here up at this big idea. Multiplying by a fraction less than 1. Is 1/2 less than 1? Yes. Yeah. And when we get 8 times a half, what do we get? 4. Is the product less than one of the factors? Yes. And then what happens when we take, which is kind of similar to what you were talking about, this halving idea. It's halves one of the factors. When we multiply a third times a fourth, what do we get? 12. Is the product less than both factors? Yes. So I want you to keep that in mind today as we start dividing fractions. And instead of using the language of factor and product, we're going to be looking at the language of dividend, divisor, and quotient. So today I want you to be thinking, what happens to the quotient when we divide by fractions? When you look at the standards and how they're written, the division standard is actually quite complex. It's not just a simple students learn how to use the algorithm to divide fractions, which is what we might see in some of the former state standards that are out there. But if you actually look at it and think about it, students need to understand and interpret the quotient very clearly, that it is larger than the dividend and the divisor. I want you to silently think to yourself and solve to yourself this problem. And even if you're not sure, that's okay, because that's what we're going to do today. We're going to figure out how to solve problems like this. All right, go ahead and turn to your partner. What do you think the answer is to 3 divided by 1/2?
1.5. It's 1.5 because a half of 3, a half of 2 equals a half, and then a half, a half of 2 is 1, and a half of 1 is 1/2.
Yeah, so if you add those two, you get 1.5, which is half of 3.
Yeah.
What were some of the answers that we had? What were some of the answers? Alondra?
1.5.
So one of our possible solutions is 1 1/2. Marlene?
6.
6. Any others out there? Jesus?
I got 1 1/2.
Great. That one's already up here. Any others? All right, so we have 2 answers. These answers are quite different from one another. So now what we're going to do is we're going to try to make sense of this. Is there somebody who'd be willing to share their thinking about how they got 1 1/2 or how they got 6?
I divided 3 divided by 1/2, and I knew that half of 3 was 1 whole and 1/2.
Okay, so you thought of 1/2 of 3 is 1 1/2?
Yeah.
Okay, and let's hear from another.
I don't know what the answer is, but I don't think it's 1 1/2 because 3 times 1/2 equals 1 1/2, and we're dividing.
Interesting. So let me get a different color here. So you are saying that 3 times 1/2 equals 1 1/2. Okay. Turn and talk to your partner. What do you think about this statement? Is this true?
We're dividing and not multiplying.
3 times 1/2 is true because 1/2 3 times is 1/2 plus 1/2 equals 1 plus 1/2 equals 1 1/2.
I did the division algorithm for the problem, and I ended up getting 2. So I'm actually agreeing with Annabelle that it might not be 1 1/2.
Okay, so you're not sure this is the correct solution, but you're also not sure what it might be. And it sounds like you've learned some sort of a procedure for dividing fractions,
Yes,
but you're not sure. You're confident with it or not sure?
I'm confident.
You're confident. Okay, so you think the answer is 2? Okay.
I remember that division means groups of. So they're trying to find how many halves are in 3, and that's 6.
So I'm looking 3 into groups of 1/2, okay? Or I could say 3 into 1/2 parts. And you're saying that's 6.
Yeah, because there's two halves, so in 3 there's 6.
Because the people that are saying it would be 1 and 1/2, that would be multiplication, but we're talking about division.
So you're saying that a multiplication problem and a division problem can't have the same answer?
Because, well, sometimes they can, but like in this case, because it's saying that 3 times 1/2 does equal 1 and 1/2, but I don't think that 3 divided by 1/2 equals 1 and 1/2.
The best part of the lesson today was listening to the students think about making sense of this problem, 3 divided by 1/2, and being so convinced that it was 1 1/2, which was incorrect, and trying so hard to come up with evidence for why they felt so strongly that 1 1/2 was the solution. There was the great moment when a few kids said, well, I know it's not 1 1/2 because if you multiply 1 1/2 times 1/2, you don't get 3, and multiplication is a check of division. So I loved hearing that. What I want to do right now is talk about what mathematicians do when they are trying to make sense of a problem. We're trying to make sense of 3 divided by 1/2, and we have 2 ideas. Most of us are saying 1 1/2. Some of us are saying it's not 1 1/2, but I'm not sure what it is. And then we've got some of you that are saying it's 6. So, is this our problem? Yes. All right. So I'm going to take out our fraction kit pieces. So we're going to try to make sense of this problem by, let's model. So if we were to do 3 into groups of 1/2, by looking at this model, I want you to look at this model and talk to your partner. 3 into groups of 1/2. How does this model help support your idea or change your idea?
What the model that you put supports my answer because 6 is also the answer, but it's because it's like how many B's go into A, and how many halves
hang
go
on.
into-
How many B's go into A? What division statement is that? Number 2. How many B's go into A? Okay, so keep talking.
So I just put like how many halves go into 3, and I got 6.
I would like to agree with my answer, which is 1 and 1/2, because if you we're dividing 3 into like its half, so it would be 1 and 1/2 if you cut that in half.
Okay, so is this problem 3 divided by 2? You're saying this is what we're doing?
Sort of.
Sort of. So you're saying that these 2 would have the same answer? Yesterday, we agreed that all 10 of these statements were true. That you could model a division statement by thinking of the dividend as A, the divisor as B, and you could ask yourself how many B's, how many divisors go into A. So if we use what Clinton said, this would be our B, and this would be our A. How many B's go into A? Does this make sense? 1, 2, 3, 4, 5, 6? Yes. Makes sense. So that whole moment of dissonance and disequilibrium around 3 divided by 1/2, which took 10, 15 minutes, was so great in hearing so many kids share their thinking and try to prove their idea and their answer with evidence. So I was thinking about what's long that we could divide? And then I was thinking, well, candy, it's Halloween's coming up. So I was envisioning licorice, although would you believe it, licorice is the only candy that I actually don't like. But it works for this model. Imagine we have a long rope of licorice. It's 2 feet long. And I want to divide, Ismail and Brian, I want to divide this rope of licorice into 1/6 of a foot pieces. So my question for you is how many pieces of licorice will I have if I divide it into 1/6 pieces? And to do this, I'm going to give you a fraction kit. for you and your partner to see if you can make sense of this problem with a model. And what I love about the Common Core in math, particularly the mathematical practices, and so for me, I feel like they have unleashed this new excitement around teaching when I'm really starting to think about not just students mastering skills, but mastering ways of thinking and thinking about how do I measure kids' ability to use models and make sense and critique the reasoning of others. So I feel like for me, it's expanded all the possibilities of what I can do with my lesson planning, and just it's challenging. So I checked in with most all of the tables except for this table, so I'm going to actually go to this table. How many pieces of licorice did you guys decide I would have? Angie? 12. And how did you figure that out?
Because like there's 6 on this side, and then we put 3 on 1/3 instead of the 6, and then it also equals 6, and 6 plus 6 equals 12.
Ah, okay. I want you to now go back to our problem, and I want you to put 3 pieces of licorice. Now your rope is 3 feet long. So go ahead and put 3 blues in the center of your table so everybody can see. And this time I want you to divide it into 1/2 pieces. 1/2 pieces.
It has to be 6 because it has 2 pieces on each one. If you do 2 times 3, that's going to give you 6.
That's gonna be 6 because like
4, 6.
because two 1/2 equals 1 whole. So how many halves go into 3? 6 of them. So 6 is gonna be the answer.
4, 6.
So are we convinced now that 3 divided by 1/2 is actually 6? Yes. All right, so here's what we're gonna do now. Now I'm gonna mix it up one more time. We're gonna do one more problem together, and then I'm gonna give you a chance to practice. And the problem that I want you to do now is 1/2 divided by, imagine I had 1/2 foot of licorice. I have 1/2 foot of licorice, and I want you to take 1/2 and I want you to divide it by 1/4. How many pieces? I think what we'll do tomorrow is continue to finish working with the problems that we started and stopping and pausing for questions. What I'd like to do before we close is just turn your attention back here to our mathematical practices, and I want you to just call out, did we work on making sense today? Yes. Yeah. Did we think and reason with a situation? Yes. Did anybody get hungry thinking about licorice? Yes. Did we use evidence to support our ideas? Yes. Yeah, that was really great. Did you guys notice, Brian and Ismail, did you notice how Jordan gave an example to support his idea? He was using evidence. And then also, did we critique each other? Yes. Yeah, we had 2 different answers for 3 divided by 1/2. Did we model? Yes. Did we use appropriate strategies and tools from our toolbox? Yes. Yep, our division statements. And were we precise with our notation and communication? Yes. We had to correct each other when we were using vocabulary, factor is product, dividend, divisor, quotient for division. And then last but not least, were we looking for patterns and making connections? Yes. Yes, we were thinking about our work with multiplying and how does that relate to division or not. So what I'd like you to do right now, we're going to close class, and for homework, I would like you to finish the page, and if you could put the fraction kit pieces away, that would be great.